Okay, consider the real numbers interpreted in terms of f of x equals p minus 3 comma 5? Oh, that must be a decimal. That must be 3.5. So that really doesn't make sense to me. Plus 2 times p minus 2x plus 6 function where p is any real parameter. I'm still not sure what you mean with that, Felix. Syllable note length? Wait, Wait, is this about something that I said? Or that I was looking at before? 8 is the length of the note. Okay. At least for this question, p is any real parameter. For which value of p will the other 0 point of the function be greater than 1? The first 0 point is -2. An eighth of a whole bar? Oh, okay. I never actually watched Frozen. And then Jed, find the values of p, but random references are always welcome. The equation has 2 roots. One root is -2, the other root is greater than 1. I assume a quadratic formula of this. Is there a different way that we can do it? It's weird to me that... Oh, the first 0 point is -2. Or maybe we equate coefficients. Because if we're given, we could do... Wait, for which values of p will the other 0 point... If we're given -2 is 1, 0, we could try to equate coefficients and get a system of equations. I think I like that a bit more. Plug in -2 to x, set to 0, solve for p. That, ooh, yeah. That might be even better. Let's try that first, because I think that's the most promising technique so far. I don't think I've used the blue yet. Let's see how well the blue shows up. So P, well, why did what are the first thing I wrote is already wrong? P minus 3.5, and I'm just gonna go straight to plugging in x. Minus 2 for x squared plus 2p minus 2 times minus 2 plus 6 equals 0. And hopefully we get a value for p out of this. So from this first term we get 4p minus That looks like divide. 3.5 times 4? Is that 13? No. Yes? 13. No. 14. Yeah. Because then 4 times 4 would be 16. Okay. That's... I shouldn't have written plus. Oh, thank you, Jed. Minus 2 times p is minus 4p. Oh no, the p's cancel. Okay, so that's what I was afraid what was going to happen. But doesn't that make sense? If the equation has to come out to be 0, the p's have to cancel. Now that I think about it. Okay, so I think this solution was worth investigating, but... Or that technique was worth investigating, but not going to be it. Hey, Skirtle. Got the doo-doo. Hope you're doing good. Okay, so maybe let's try equating coefficients, because we do have... Okay, actually, well, now I'll just rewrite the original function. Down here it's more confusing. Here to admire the new Vegas flag. Oh, yeah. Wait, which way do I move? There we go. There you go. This is what the rest of the stream will be. I'm just going to stay still, even though it's, like, cut off. P minus 3.5 x squared plus 2p minus 2x plus 6. And we also know that if negative 2 is a 0, it should be equal to... Oh, we get 3 variables. That might be okay, though. Let's say a times x plus 2 times x minus b, let's say. And actually, no, we don't need a, because we can do p minus 3.5. It has to be that coefficient of x squared, doesn't it? Otherwise, math breaks. He's giving you a better view. You're welcome. I'll look at that in a second, Jed. P minus 3.5, x plus 2, x minus b, I'll say. Bring that up. My dial-up loads it. Which says I'm your biggest fan. I didn't know that you could like share your watch streak. I've never seen a button for that. Whoa! Hello. Oh, when you cross the 3.5 mark, that makes sense. You just get a line exactly at 3.5. Oh, that's the share link? Okay. You can also automatically do it. Okay, well that makes sense. That's just manipulating the leading coefficient of a quadratic, basically. I remember on a band stream, they're playing around with I think it did like x to the p plus y to the p equals 1 or something, and when you made that slide around, it looked like a flying squirrel at some points, or I don't remember exactly what they did, but it was something like that. They were looking at some weird like functions. Oh no, the person closed it. I wish I remember what that function was, because it reminds me of like in a video game, like a loading screen, like simple like image that flies around to let you know that like your game hasn't crashed. Yeah, Jed, I still want to see what the solution to this is going to be. But yeah, it's like one of those little like loading screen, it's like graphics, I guess, is what it reminded me of. So if we multiply this out, we can do some equating of coefficients, and that's going to be my strategy. Well, I guess we still have another strategy of the quadratic formula, but I don't know how that's going to work, so I'd rather try this first. So I want to multiply all this out. I guess to the p minus 3.5 part last. X squared. Wait, we get minus xb plus 2. Okay, so plus 2 minus bx minus 2b. Okay, 2b or not 2b. And then now let's multiply in the p minus 3.5, which I don't actually want to FOIL this. I want to just treat the p minus 3.5 as one unit. So p minus, 3.5 x squared plus p minus 3.5 2 minus b x minus 2b p minus 3.5. Okay. So now, if this is equal to that, then the coefficient of x squared should equal the coefficient of x squared, which isn't that helpful here. But the coefficient of x should equal the coefficient of x, and the constant should equal the constant. So we have two equations, two unknowns. I assume we can solve for the other zero, which is going to be b. Okay, it's going to be, for which values of p? There should be, oh wait, is it? I might have missed something obvious with this problem. Maybe not. Okay. If there isn't a really simple, intuitive way, I don't see it right now, but I've never gone too deep into the algebra weeds without just thinking about what a parabola means. So that'll 0? No. I want to equate the coefficients. So I think setting equal to 0 is not what we want from this stage. It doesn't really make sense to me. So I would equate the coefficients of x squared, but they're the same exact thing, so that's not going to be anything helpful. But the coefficient of x is 2 times p minus 2 is equal to the coefficient of this x, p minus 3.5, 2 minus b. And this constant 6 must be equal to that constant there, minus 2b, p minus 3.5. I mean, we could set equal to 0, but we can't actually find the roots of that without quadratic formula, and just using the quadratic formula might not give us anything helpful. This is two equations, two unknowns, so in theory, you should be able to solve it. In theory being the keyword. I think I'm going to... Ooh, what's easier here? Okay, I want to solve this one in terms of b and plug it into over here. So I think that's more likely to give us a helpful answer. It's going to be b equals 2 minus 2p minus 2 over p minus 3.5. And I want to do this because we get the p minus 3.5 on the bottom, and we're going to have p minus 3.5 on the top. Make sure that I didn't do anything catastrophically wrong already, but I think that algebra works out. So let's plug this b in up there. So we get 6 equals minus 2. Let me actually... Ooh, I don't want to do that. Yeah, let's keep it like this. Minus 2, 2, p minus 2. There's a lot of 2's floating around here. p minus 3.5. Let's try and solve this for p. It shouldn't be anything that bad. Actually multiply this all out too. So we get minus 2 times 2 is minus 4 times p minus 3.5. So minus 4p plus 14. Okay. Then this term, minus 2 times minus that becomes plus that. P minus 3.5 cancels. So we get plus 4p. No! You're kidding me. The p's cancel again. What the heck? I guess maybe you do have to quadratic formula this. And I'd rather not, but... Okay, let's just try it. I feel like I'm invested in this problem now. Wait, why isn't... My headphone cord is stuck on something. What is that thing? Okay. Whatever it is fine now. Okay, I'm going to take this and apply the quadratic formula, I guess. Minus b plus or minus square root b squared. I mean, this square root might not... we'll find out. Minus 4ac over 2a. Okay. That makes sense, I guess. That checks out. Okay, let's try and work out this monstrosity. And at some point we're going to take the minus case and set it equal to -2 and try and get some kind of relationship for p, I guess. So that's 4p squared minus 4p times 4 is minus 16p. Positive 4 becomes 16, okay? Minus 24p. 24 times 3.5, that's not mental math. Actually, I can do it in the reverse order, right? I can do 4 times 3.5 is 14. 14 times 6 is 14 times 6. 28 times 3. God, I shouldn't do this in my head. Hey, cooks. Wolfram said 24 times 3.5. $84. Okay, I was getting close. Minus minus positive, so positive. Said 84? It did. Hopefully that factors into something not horrible. 2p minus 7. Okay. Even if it doesn't, I think we can still work with it. I'd just rather not. Okay, so minus 2p plus 4 plus or minus square root. 4p squared doesn't combine. Minus 16p minus 24p is minus 40p. 16 plus 84 is 100. We can take a 4 out of that and maybe get something factorable. I think we do. Oh, that's going to be x minus 5 squared. Oh, p minus 5. Because that becomes p squared minus 10p plus 25. I believe that. Okay. I'm not cutting off. Okay, good. Dan. Oh, yeah, he did. Oh, and Brian, too. Hey. And give it a delay so Nightbot doesn't yell at me for shouting out too quick. Okay. Okay. Actually, wait. Oh, well, okay. I'm trying to look at my... Okay, good. I want to make sure that the far side of the whiteboard wasn't getting cut off. No worries. Okay. So that is a perfect square. 2p plus 4 plus or minus 2, p minus 5. 2p minus 7. Okay. So we're given here that it doesn't say it on the actual image, unfortunately, but the first 0 point is -2. And if we're interested in ones that, and the other 0 being greater than 1, then that -2 must come from the minus case, and the one greater than 1 must come from the plus case. So I hope that we can take the minus case here and set it equal to -2 and get something for p. It would be one value for p, which seems weird. I thought we'd get a line. Maybe not, though. -2 is equal to -2p plus 4 minus 2p minus 5 over 2p minus 7. Okay, there's a lot of p'ing happening here. -2p minus 2p is minus 4p. 4 plus 20 is 24, last I checked. Okay. Now let's multiply by 2p minus 7. Okay. No! Oh, wait, no! Frick, the p's cancel again! I literally can't with this problem. Everything I try, the p's just cancel out. What do you do? I don't get it. I've tried 3 different ways, and the p's just cancel. I literally think to myself, oh good, I'm glad the p's don't cancel on this one, and then they cancel on me. I don't know what you do for this. Do you take the plus case and just try and look for where p is greater than 1? Like set it equal to greater than 1? Okay, let's try that. Before I rage quit this problem, let's try that. That's actually not even a true statement. Did I do something wrong? You'll get 14 equals 24. I don't know. I'm forgetting about that. Oh my god. I can't believe this. 2p minus 7 greater than 1. Let's just see if this gives us anything. 2p minus 7. Is it dangerous to multiply each side by that? It is sometimes negative when p is less than 3.5. But we're only interested when it's greater than, when it's positive, I guess. So I'm just gonna multiply it and see what happens. I don't know if this will be I don't know, I hope this is valid. We can check it manually in Desmos too. One half? Oh, that might have gotten cut off, I'm not sure. Oh no, just barely enough room, okay. So Okay, let's see if p greater than 1/2 gives us what we want. And if not, then I'm just gonna rage quit this problem, but... So we didn't even, if this does work, we didn't even need the other 0. So when p is exactly 1/2, what do we get? One of the zeros is -2, the other one is just below 1. Okay. Wait, that's 0.2. There we go, that's exactly at 1. Oh, so I did do it right. Hey, okay. So just p is greater than 1/2 is your answer. I I have no idea why you get a statement that isn't true when you do it with -2. I'm just not... Wait, wrong? What did I do wrong? Keep increasing p. Oh, okay, you'd have to give an upper bound. True, Jed. Thank you. So wait, how do you... Okay, well, we can see the upper bound is at 3.5. Okay, yeah, so it... Okay. You're right, because once you go... It has to be p... 1/2 is less than p is less than 3.5. So 3.4 works, 3.49999 works, but 3.5 exactly does not, because that's a line and only has 1 0. 3.6 and greater doesn't work because it's an upward parabola. Okay, he's like, oh, okay, I didn't know you could do it like that. Oh no, okay, oh well. Oh, okay, I can get it back though. Yeah, no, I mean, this is what I expected. Or this is how I expect it to behave, so. Okay. Well, that's an instructive problem. I'm glad I didn't rage quit it right then when I was so close to the answer. It's not really, it's not going to be a true vertical asymptote. It's going to be a really narrow parabola. But a parabola, it'll never have a vertical asymptote like that. Like a true one. It'll just look like one. Oh, at x equals 0? Oh, I mean, it'll look like it has a vertical asymptote at x equals 0, but it will cross over. This will eventually hit every single, you can plug in any real x you want. So you could go all the way over to the right here. Yeah. No matter what your leading coefficient is, a parabola is always defined for, the domain is always all real numbers. The range, it has a minimum for an upward facing parabola, but no maximum. Okay. So as I said, that one did get closed, unfortunately, before I could answer it. To be fair, if I answered it, if I didn't bring myself on a wild goose chase, maybe I could have gotten there first, but it doesn't matter. Still instructive. Really? An altitude of 6 miles, at a speed of 550 miles per hour, relative to the ground. Get some related rates, I guess? I don't know if this needs to be said, but I think they could have phrased that in a nicer way, but I haven't done related rates quite like this. I'd be interested. I wonder if I can work this out though. Let's try it, drawing things out a bit. See if we can figure out what's happening here. Okay. Call that good enough. Let's erase what we have here. Ugh. This is all my arm workout for the day right here. Why did my leg fall up, or fall up? my leg fell asleep while I was standing up. I don't know how that works. Wait, okay. So let's try green. Relative to the ground. We have a radar station. Beep, 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 beep. That, I don't know what that's supposed to be, but radar station. A plane flies over it. Oh god, how do I draw an airplane? It's gonna be a fish, and you guys are just gonna have to deal with that. Okay, my best airplane. Wait, do planes even have a tail like that? I don't know. I can't remember what a plane looks like now. Take off the bottom fin? Okay. Okay, that does look more like a plane. There we go. I don't know, I guess my mind just went to fish. 550 miles per hour.
Oh my.
Oh my. Constant altitude and speed. 5 miles. Wait, 6 miles. I can't read. The distance. Maybe I should actually be drawing this differently. Wait, I'm trying to set up like a right triangle. I guess I'm getting confused with the angle, with the elevation of the building versus the like altitude above the building or altitude above the ground. But I assume we just take one side of a triangle as 6, because they don't give us the height of the building or anything like that. So maybe I should make part of myself than I have to. So technically, it's a triangle that goes like this, just right through the building. And we could also have drawn that triangle flip. That might make it a bit more clear too. What's actually happening. Actually, I do want to draw that triangle flipped. Makes me happier.
Okay, 6 miles. We're going 550 miles per hour. We're saying to the left.
The direction isn't actually relevant. As long as it's a straight line. Straight line over the station, I think is safe to assume. Actually, I don't know if that actually matters that much.
But we want the rate of change of the hypotenuse. I should have drawn this differently. Why did I draw it flipped? I flipped it again. Okay. One day I'll draw this right. Okay, so the distance from the station, I'm just saying the bottom center of the station, to the plane. Let's just pretend we're going from the nose. Is that hypotenuse? 6 miles. There we go. That distance, I guess let's call it D. And maybe that X. So we know what X is changing by.
We want it at the moment. How fast is the distance changing when the plane is 10 miles from the radar?
We want D prime. When D equals 10, I guess is our goal.
And so when D is 10, we can use Pythagorean theorem to get X. Shouldn't that be 8? This would be a 3, 4, 5 right triangle. I think X is going to be 8.
It's root 36 plus x squared. Nope, not root if I already squared it. 64, yeah, x equals 8. Hey, that problem of the week paid off for the Pythagorean triples. What do I think about this problem, though? So D, we do need the Pythagorean theorem here, I guess. Okay, so if we have... If we know that D squared... Okay, I'll call that x and that y is equal to x squared plus y squared. Wouldn't we differentiate this to find D prime? Would we want to square root it first? And only take the positive square root? I guess so. Yeah, we can do that. Because we don't need to worry about the negative square because we're talking about distances. So, ooh.
Y is a constant, though.
So what if I just not worry about the y and just have the 6 there? I thought keeping it general for a minute would make it better, but I don't think it does. When are we using the 550 miles per hour, though? We do it like this.
Oh. Expressing x as a linear function, that might be a lot better. You're saying to evaluate it at that moment. That'll be, I think, the time when it happens, but not the rate of change of the distance.
But I think you do make it, because I think I am missing here that we want this to be a function with distance and time, and x is a position, but we know that x is equal to speed times time. So we could plug that in over here, and I think that might be why this felt wrong. So it does make way more sense if d is a function of time for this problem. So if we derive this, set d equals to 10, we can solve it for t. Oh, no, no, ooh. No, we need to derive it, and we already know that t should be 8 divided by 550. Okay. So d prime is equal to, well, okay, let me simplify this a bit more before I do the derivative. 550 squared, if anyone has that memorized, then I'd be impressed. What? Wolfram Alpha doesn't get 55 or 550 squared? How's that possible? Okay, now it gets it. 302, 500. T squared plus 36, and then we get it back to the problem. Okay. Now we want to derive that. Oops, I messed up my square root. Okay, so d prime is going to be 1 over 2 times that times chain rule times, oh god, 605 00t 0. Yeah. 605,000. Now we know that t, when x equals 8, t equals 8 over 550 equals, what do they definitely have 2 as a common factor. That's going to become 275? Okay. So we plug in 4 over 275 into that, which I'm going to let a calculator do. Wolfram Alpha? Oh, the times 2, yeah, I did almost forget that. But I think that's just our answer once we plug in the value for t. Let's find out. So, 605,000 times, and actually, because I don't trust my mental math, I'm going to do 8 over 550 divided by 2 square roots, 302, 500, 8 over 550 squared, plus 36. Or 40. That seems reasonable. Okay. Let's flip back over to the Discord. And they got an answer. Okay, well, we just did some more math for fun, I guess. Dude, I cannot catch a break today. Just actually being able to help people. Like, this is some fun math.
Oh. I assume they're asking about convergence here. So the one on, you can split this fraction up. The one on the right is a P series. And P is less 1. Doesn't this just diverge? And the other one could be compared with the first one. Oh wait, they're subtracted. Hmm. Oh no, they came back? Oh, but at least they got banned. Okay. Well, finally. Okay, so managed to get proof this time. Oh, nice. I guess it is hard to like want to ban someone without proof, but it's kind of crappy that you have to deal with that. Oh, like telescoping? It could be telescoping. You're right. I didn't even think about that. Oh, isn't this just? Oh, okay, Felix. Thank you for saying that. I think this might just be telescoping. Let's write out a few terms here. I feel like I should have realized that a lot sooner. Okay. Oh, you know, if I have a channel redeem to draw it, maybe I should have another channel redeem to choose what color I do a problem in? I don't know if people would care about choosing that, but I guess I could try it and see people redeem it. I'll do orange this time just to mix things up. Spectry with 3-stream watch streak. Tie-dye rainbow? You have to switch colors every 2 seconds. I'm just gonna have a marker in like between each finger. Oh my god. draw them all at once. Okay, so looking at this series, the orange, I don't know if that shows up too great on stream. The multiverse of math. No, it's a little too hard to read in my preview. You can't play any of the sounds? The orange is mid? Yeah, I agree. Do you not have enough points, or are they actually not working? Let's go back to blue. Like Freddy, but with colors instead of scissors, you just not going through. Someone played Jed played Oh My earlier.
Shit.
I love that one. I don't know why it's not working for you. Yeah, maybe refresh or something. Call a doctor. I don't know. I'm fine. Everything is fine. Okay, from n equals 1 to infinity, root n plus 1 minus root n over n. So let's just plug in a few terms here and see if it's telescoping, because that's a very good call from Felix that we should be checking that, and it probably is telescoping, honestly. So I am going to actually slightly rewrite this. This is equal n plus 1 minus root n over n, because it'll make it more clear if it's telescoping if we do this format. So with n equals 1 for this whole thing, we get root 2 over 1 minus root 1 over 1 plus, I'll do brackets for each term. For n equals 2, we get root 3 over 2 minus root... No!
It doesn't telescope because we should. Wait, no, yes, that's 1 and 1. Never. Wait, no, but they're both subtracted. Am I doing a stupid right now?
Yesterday, both Central and Skirtle redeemed the draw. And Druha. Or no, whenever I first implemented it, I had three people redeem it.
So maybe this isn't telescoping.
Extreme! Parkour!
Hey, that's... Oh my god, I even said that one was gonna jump scare me. Yeah, no. Oh my god. Oh. I was maybe avoiding putting in jump scare alerts, but that one really gets me. Conjugate? I was thinking about trying the conjugate. I didn't know if that would help or not, but I do think that's something that's worth trying. I didn't say it out loud though.
Yeah, I don't think this is telescoping, unfortunately. That is a great thing to check for, but it doesn't seem like it for this case. I feel like there's Can we show that, like, this almost feel like a... How does this compare with... Never mind. I was thinking we should compare it with root n over n, but that's not a clear comparison for greater than or less than. So yeah, maybe let's consider what happens if we multiply by the conjugate. I don't know exactly what's going to happen here, but maybe something helpful. Oh, maybe we can get a p-series if we do that. Or we can compare it with the p-series. Because this, we get all the n's on the bottom, and hopefully we get something simple up top, like just a 1 or a constant. N plus 1 minus n, good. N root n plus 1 plus n. Okay. So we just get 1 on top, which is perfect. Okay. Root n plus 1 plus root n. And so this,
The degree on the bottom? The Mona Lisa? Oh no. Okay, well, let me just finish this train of thought and then I'll draw my masterpiece. Oh, for the announcement? Yeah, that's gonna be in 3 hours from now that we're gonna have that math streamer meeting of the minds or whatever. Yeah, and if, otherwise there's always like the bottom stuff if you're that interested, but I think it's gonna be really fun to just like talk and see what everyone is thinking.
so the degree on the bottom here is 1.5, I guess. We should be able to make a comparison here. We should have what we want is that's less than or equal to, oh my god, my sigmas are getting worse and worse. 1 over n root n. And I think this is valid because this denominator is bigger, and a bigger denominator is a smaller overall number. And this is a p-series that converges. So by the comparison test, this must also converge.
Nerds of the round table? Someone said that exact thing. Was that you?
I don't remember.
I remember someone saying nerds of the round table at some point. That was you? Oh, okay. Yeah, okay, that's right. Okay, so actually, that's a save from Dan. So I think that's just the answer right there. So let's see if someone beat me to it. And the answer is almost certainly yes, but that's still a fun one to know.
Oh no. No, don't do limit comparison. Wait. That doesn't telescope. You can compare it with a similar but simpler series. Or from this state, I would try the comparison test with 1 over n square root n. Felix, this is a mathematics Discord where there's these like math help threads and also a bunch of discussion threads. It's pretty cool. Let me, I should have the link posted to it in my Discord. Oh, did someone put a question? I didn't even see that. That's the link right there. Oh, I'll deal with this in a little bit. And actually, I don't know why I'm hiding my Discord here. I just want to see. Oh, you posted the clip of me central? Yeah. Yeah, let me see how much I jumped by. There's a good one, like, with an alert that Hardlocked got me with. I don't know where the clip is, though. But it's definitely not the first time I've been jump scared like that. I'll pause my music because I don't want to hear the, or I want the music in the clip not to like conflict. Oh no, frickin'. Okay. I really need to get an actual VPN. Redeem the draw. Drupa. Or no. Whenever I still owe Spectry. So maybe the Mona Lisa. Oh, you have. That's a really good jump. Hey, that's. Oh my god, people are gonna abuse that. I got air, yeah, I did. Yeah, it isn't the cheapest thing. Fight or flight, yeah. Actually, make sure the person hasn't replied to me. The self-solving markers seem to make a lot of mistakes. Actually, okay, let me. Oh, okay, that person. Oh. I'm just. Okay, there we go. I was gonna say that. Smiling Dawn watching Smiling Dawn. All right, now Spectry, you did pay your hard-earned channel points. I need to make a name for my channel points still. So the Mona Lisa. I assume you're not gonna hate me if I use a reference here, because you know I want to make this good. Actually, I'll keep that up. Why not? Mona Lisa. Here we go. Because you know this is gonna be an exact match here. You know I don't need a reference. this isn't gonna help. Never mind. Okay. Maybe, I don't know, I'm not a huge fan of the orange though, but I feel like it is a pretty orange painting. Actually, should I erase this? Yeah, I'll erase that. I'll put it over in the corner where you can see it. Okay, bye marker. See if I care. But first, we obviously need a frame. Something like that should do us. You know, I don't want to use red either. Okay, let's do the outline in black, and then we can do some shading. I need room to do math though too. It's the technique. Oh, okay, good. Yeah, because I'm about to blow your mind here. Wow, I didn't know there's like a little table at the bottom. Okay, so let's start with the table. That seems like the simplest thing. Shit. Now they're working for you, Central. A little table like that. Just do a straight line, so her arm is gonna be on top of it. Dude, this is gonna be so hard. Just focus on the edges for now. Okay. It's kind of all like, oh god. Don't worry, this is just, This is bad, that's what this is. Dang it. I should have thought this through more. I have to draw the Mona Lisa right now, PhD. I don't know why I put this channel point redeem on now. Spetrius pointed out the flaw in it. Okay. Let's, how the heck am I gonna do this? Got a hand there. Get some little fingies going. Perfect. That's exactly how I want that. Her other hand is over the top of it. Some more fingy wingies going. Yeah. That time I was ready. Yeah, if you can't see that this is already the Mona Lisa for my flawless technique, then, you know, I don't know what to tell you. Wait, no, it needs to be resting on the stool or table thing. Her arm. Sorry, I already messed up her hand, but, you know, we'll just... We'll compensate.
Correct. The best kind of correct.
Not how you milk a cow. I don't know what that means. Okay. Go for the outline of her clothes, I guess, right now. Okay. Good. Got a little arm there. Perfect. Oh god, this is... Don't make fun of her for the length of her arms, okay, people? It's just, you know, she can't control the length of her arms, okay? So I don't want to see anyone making fun of her for having extremely long arms. I'm putting way too much effort into this because it's still gonna come out crappy. I guess... Hey, you know, let's just try orange because, like, the entire thing just has an orange tint. Yeah, no body shaming here. It's gonna look like she got a spray tan, and you also can't judge her for that either. Okay. Oh God. You know, it's not done yet. So trust me, this is gonna be mind blowing. Now, is she smiling or does she have a straight face? We'll never know. She's like smirking. I should have made her hands orange too if I'm gonna make. This is all bad. She also has orange pupils. She's spray tanning her face, but on her hands exactly. Okay, we got some hair. I can handle that. Beautiful. Okay. Wish you might wear gloves. Okay, jeez, thanks for the follow. And I disagree. I think this is a perfect replica. Once I'm done, I'll put them side by side, and I'm going to challenge you to find the difference between the two. There we go. Now spray tan's a bit more even. Self-portrait? Oh no. This is a mistake not having Chandler redeems for so long. Now everyone can do it. I mean, we're almost here with the Mona Lisa, though. We do need a little bit of background. There's a little bit of a river in the background, very tastefully. So let's get that in there. Okay, got a river. We do need some happy little trees above the river. Really crappy trees, but you know, this is how Da Vinci drew them. This might look bad, but just blame Da Vinci. Because I'm just doing what he did here. I could obviously do much better. Okay. Oh no, it's Spectre. This was a self-portrait. Okay. What else do I need? I don't know. This feels like it's pretty much there. There are some like rock things, like weird, like small little hills around here and here. But you know. You look me in the face and tell me that these are different, okay? Like, wait, I don't want to point at my own face. I'm still in the self-portrait thing, but like these two things, exactly the same. Just an actor, yeah. Okay, so that's the Mona Lisa complete. Now we have a self-portrait and a self-portrait of me drawing a self-portrait. I think I improved it, or you think I improved it? Thank you, Peach Tea. Okay. So, self-portrait of me, let's start with that. Dude, I think it'd honestly be a lot of fun to do like a Bob Ross stream. It would not come out well, but it's something that I think would be fun to do one day. Okay, so a self-portrait of me, I'm gonna make this as realistic as possible. Did the Pearson switch them? Yeah. Yeah, no. I need to look. I think I sell actually like Bob Ross like kits, right? So you have everything that you need to like get going. So okay, I usually wear pants, so let's start with pants. Usually pants, not always. I got some nice feet. Yeah, look at those babies. Please don't make fun of my non-symmetric feet. I'm very insecure about it. Okay. And, you know, I don't want to gloat here, but I do have amazing muscles. So let me just, I'm going to tone them down a bit, but God. Yeah, here's my here's my muscles. This is so bad. And, you know, I'm just wearing a tank top. That's what I always wear. At least an 8-pack? Yeah, I think you're right, Dan. Through my tank top, by the way, my 8-pack still shows. Got some nice hair too. Can't forget that. Okay. And I also have a spray tan. You can't tell. Oh, dude, this orange blows. Oh, I just because I just like wrote over some black things with it though. Now it's a bit better. Oh, can't forget my neck. There we go. So, you know, I gotta say, like, maybe I need to do the pose, but I think this is pretty dead on. Yeah. I feel like I don't have red hair though. I don't know. If I had brown, I mean, red is the closest to brown that I have. So I'll do it for that angle, if nothing else. Remember, I do need to do a self-portrait of me doing this self-portrait after this. Okay, I'm going Super Saiyan or something. Oh, the beard! Thank you. I forgot about that. Dude, how can I forget my magnificent beard? Stash too. It does cover my eyes a bit, but please don't make fun of me because I'm also insecure about that. Yeah. Oh, you know, I forgot to get my feet spray tan too. God forbid I don't get head to toe spray tan. Yeah, exactly. I was thinking like I'm going Super Saiyan or something. Okay. Now there is another self-portrait that needs to happen here. And thankfully one leads into the other. Because now we can just do this. Hey. I didn't even count the number of toes, but you know, I never counted my toes before in my life. Okay. This is... I got muscles like clouds, people. It's all the rage. I have my marker here. You know, I need some more room. This is... My Majesty cannot fit into a portrait this small. Okay. Good. How do you draw like a concentration face? Like, that seems kind of concentration-ish. And I need that little painter's hat, right? The little thing on it. Should we have... No, this isn't cheating. I need to draw self, you know, it's 2 for the price of 1, but... Okay. I'm drawing without looking at the drawing. You know, when you're as talented as I am, looking at the thing you're drawing is really more of a crutch for an amateur. Oh, you know, probably the frame shouldn't be going through my arm.
Ta-da! All right, now, can you spot the difference here? Oh my god, okay. That is ridiculous. Get a channel for my drawings? We could. That's some points well spent. Glad I gave you your points worth. Ugh. I did get burned. Okay. Where was I? So this person said the question got resolved for the series. So we have helped out one person today. I always help out one person. You like how the Mona Lisa turned out? I'm glad. Another satisfied customer. Ooh. So this is a vertical ellipse because the x values are the same. I mean, the center should just be the midpoint. You can immediately the x, so like you can immediately narrow it down to a and b because you need x plus 2 for that one. All these others have the wrong x for the center. Yeah. Oh, and then even here. Yeah. So you just throw it out based off the center. Your center for y should be -4, so I think it's a. You don't even need the foci, do you? You can eliminate answers based off what the center of the ellipse should be. For example, if the vertices both have midpoint of the foci is also the same. Oh yeah, that makes sense. Both have x coordinates of -2. So we can immediately narrow it down to A or B, since those have the correct center for x. And then I want to ask them what they would do for y. You can use similar logic to, or you can also do you know how to figure out what the y coordinate should be? We'll also use the vertices.
I mean, they could use the foci too, so let me just not give too much of a hint. It's like if they were asking what the A and B should be, that would be a different question, but all the A's and B's are the same, so it's kind of a weird question, honestly. Wait, was it Tony? Okay, yeah. I remember. Help for Tony. Oh wait, they're already getting back. Okay, let's just not move on too quick then. H, K is the center of the ellipse. Oh, so I did miss that part. But H, K is the center of the ellipse. So what I said still applies. You could look. Oh shoot. Well, if you want to find. Oh. Okay. Sorry, I did miss that you specifically asked that. But H, K is the center. Yes. -2, -4? Yeah. You're fine. See if that's all they need. So if you wanted to actually calculate it without the benefit of it being multiple choice, then you have a slightly harder question. Thankfully, they don't have that question though, so I don't have to deal with that today at least.